All right, let's start correcting this practice exam. So here we go. First 15 questions are multiple choices. So here, question 1. Question 1 is about the vertical asymptotes. Let me get my pen. Here we go. Vertical asymptotes, all right, of this equation. So what you should do right here, you know the vertical asymptotes, you should know, come from the denominator. They make a denominator equal to 0. What you should do if you can is factor top and bottom, numerator and denominator. So let me see. The denominator is, that's an easy one, okay, x plus 2 times x minus 1. Don't make a mistake here, right? Plus 1 is a sum, plus 2x minus x, yeah. The numerator, so either you see it factors or you don't see it. So I'll approach it in both cases. But let's look at it right now. If you see that it factors, then you can write it, you have to group it to factor, right? This would be x cubed times what? Times x minus 1 plus x minus 1, right? So, and you see you can still go further and factor this x minus 1, okay? So it is x cubed plus 1 times x minus 1. Uh-oh, this is an old one. X cubed plus 1, we know it. Let me see, I'm sorry, I'm just looking. Yeah, x cubed plus 1, we know it. Let me remind you of the formula. How do you factor a, oops, that's too thick right here. Here we go. Let's erase that, okay. How do you factor a cubed plus b cubed? This is a plus b times a squared minus ab plus b squared, right? And how do you factor a cubed minus b cubed? This is a minus b times a squared plus ab plus b squared, right? Okay, b squared, not b cubed. I said square and I wrote a cubed. Okay, all right, so b squared right here. Okay, so let's finish this factorization then. So this is, at the top I have x plus 1 times x squared minus ab, so this is a minus, not a plus, minus x plus 1, x cubed plus 1 plus 1, and then times x minus 1, okay? So again, factoring the top was not necessary. There's other ways to do that, and I'll show you. But right now, some of you may recall how to factor top and bottom. So here's the factorization at the top, and here's the one at the bottom. And so right away, you see that this term cancel with this one, all right? Which means there is a hole in the graph. Well, let's look at all the different choices. X equals negative 2 and x equals 1, this is where the bottom is equal to 0. Okay, this is where the denominator is equal to 0. So I know my denominator is going to be 0, but that doesn't mean you have a vertical asymptote. So what do you do if you don't factor the top? If you don't know how to factor the top, how can you check if this is correct? So look, you have your bottom. Okay, here, let's write the top. x4 minus x cubed plus x minus 1, right? So, and at the bottom, I have x plus 2 times x minus 1. So, for the vertical asymptotes, you want that to be 0, but this cannot be 0. So, that 0 is easy. It's x equals negative 2 or x equals 1. So, if you cannot factor the top, just plug in the value and make sure it doesn't make the top equal to 0. So if, here, let's go. Let's plug in x equals negative 2. So if x is negative 2, we have negative 2 to the 4th minus negative 2 cubed plus negative 2 minus 1. So this is 16, negative 8 plus 8, minus 2 minus 1. I don't need to look at what it is. It's not going to be 0. If x equals 1, we know from our factorization that we should find 0. So let's see. So if x equals 1, I'm factoring. So I have negative 1 to the 4th minus negative 1 cubed plus negative 1 minus 1. So this is 1 plus negative 1 cubed is negative 1 minus it's plus 1 minus 1 minus 1. Well, this is 0, right? So this is a vertical asymptote, but this is not a vertical asymptote. So it's a bit longer. If you don't remember how to factor the top, you got the plug-in, it's a bit longer. And if you factor the top, you got it right away. You see that, what's going on here? You see right away that x equals negative 2 is the only vertical asymptote, okay? So let's fetch this answer. I just want x equals negative 2. All right. Well, and it's not there. Okay, well, it's x equals negative 2, the answer, and it's not there. So you know what? Maybe I really should have none of these. That's E. E would be none of these. We call that a mistake. Okay, all right. None of these for the first one. Okay, this question actually reminds you of all the results. So let's see. What's that? F is at the top, G is at the bottom. Top equals 0, bottom equals 0. I don't know if you remember, but these will give you the zeros of the function or x-intercept. X-intercept of the function. If the top is 0, but not the bottom. What's that? The bottom is 0, but not the top. This gives you the vertical asymptotes of the function. Both of them are different than 0. Well, it's just give you nothing. It's just a point. Point on the graph, okay? You just plug in, you find the output point on the graph. And both of them are 0. This is a whole. So the answer for 2 is D. And the answer for 1 is none of these. All right. Okay, answer for 3. This is a very important technique. I stressed it when we covered it. When we covered this material, it's about finding the inverse function. So there's a couple of steps, 3 main steps, right? Step number 1, replace f of x by y. So y equals x minus 1 over x plus 2. X minus 1 over x plus 2. Step number 2, switch x and y. X equals y minus 1, y plus 2. Step number 3, solve for y, okay? So step number 1, replace f of x by y. Step number 2, switch x and y. Step number 3, solve for y. Okay, and of course this is a main step. So how do you solve for y? Okay, don't lose track of what you're doing. Y is here and there, and if I solve for y, I just want to write y equals, right? So I'm going to multiply both sides of this equality by y plus 2 when I have x times y plus 2 equals y minus 1. I want to put those two y on the same side of the equation, but you see this one is involved in a product here. So I don't have any choice. I have to distribute to grab the y. So this is x, y plus 2x equals y minus 1. I want to solve for y, so I have to have my y on the same side, right, of the equation. So I'm going to move this one right here, and this quantity, I'm going to move it there. So x, y minus y equals negative 1 minus 2x. Okay, let's continue here. All right, how can I solve for y? Well, you need to factor. This is x minus 1 times y. You see, if you distribute here, you're going to get back to what you had on this side right here, okay? Equals negative 1 minus 2x, and that's it, we're done. So y is negative 1 minus 2x over x minus 1. Now, I don't like all these negative signs, so personally, it's okay, you can stop right here. Although I'm not sure. Let me see. Yeah, the answer is not here, okay? That doesn't mean... what's that? negative 2x minus 1 over 1 minus x. No, that's not the same, right? So that doesn't mean it's not there. That doesn't mean I made a mistake. Let's see what happens when you multiply both sides by negative 1. You find 1 plus 2x, and the opposite of x minus 1 is 1 minus x. Is 1 plus 2x over 1 minus x there? Let me see. Okay, come on, this is really slow. Yeah, it's the first one, right? 1 plus 2x over 1 minus x. The answer is A. Let me check again. This going up and down is not really 1 plus 2x over 1 minus x. Yes, because what I didn't tell you is that this is now, you replace y by f minus 1 of x, okay? And this is it. All right. Okay. This, okay. No. This one right here. Okay. So what's going on right here? We have to solve an equation. My variable is at the exponent, so you know what can happen here, right? If the variable is at the exponent, you may use log. It's way too sunny on my face. I need to pull down the shade. I'll be back. Much better. I hate using sunscreen when I do math. Okay, so you know, you're running into the potential of using log here because the variable is at the exponent. But in this case, we see that we're not going to be using log. Let me see. There's another mistake in number 4. I'm going to send an email quickly before you spend a lot of time on there and correct the errors. I think I should have had A right here. I forgot to write A and A and A. Okay? All right. So, what's going on here? You get a common base. It is possible to get a common base for this equation. So it's 3 to the power of 2x equals 27 is 3 cubed to the power of A. So what is 3 cubed to the power of A? You multiply the exponent, right? And now that you have the two bases the same, you know, the function is 1 to 1. This is an equality of output, okay? This is the output of an exponential base 3, and this is the output of an exponential base 3. If two outputs are equal, then the inputs have to be equal, okay? So x is 3a and x is 2x is 3a and x is 3/2 of a. And 3/2 of a is number C. That's great, number C. Letter C. C, in case you nobody told you so, is actually not a number. You need me to discover things like that. I am the king of the obvious. Okay. Number 5, range. Range of this function. So, the range has nothing to do with this right here, right? This is about the domain, and actually the domain is all real number. We know that. Domain of an exponential is all real number. So the range is about this thing right here. Now, you know that the regular e to the x has an asymptote, right? This is y equals e to the x. It has an asymptote at y equals 0. And so the range is above the asymptote. So let's see what's going on here. First of all, that's going to be the boundary of the range, okay? It did move down 2. The graph moved down 2. And this tells you you got the reflection across the x-axis. So that means the graph actually looks like that. Here, you move down 2, and it got reflected downward, right? So I'm expecting my range to be from negative infinity to negative 2. A is the answer. Okay? All right, let's continue. 6. Oh, this is a log thing. We know how that works. This is the properties of logs. Quickly, maybe I can quickly jot them down. But this is your job to you know, figure out everything you have to use. But let me jot them down. I'm gonna use ln. Okay, that's the quickest log to write. It's true for any base. Log of a product is the sum of logs. Log of a ratio, and this is a very common mistake, right? It's a difference of logs. And then log of a power, you can take b out, ln a. Okay? And of course, if b is -1, I mean, I use that all the time here. Let me write it here. It's a special case of that. I use it all the time. A to the -1 is 1 over a. And so a -1 goes out. So it's negative ln of a. Okay? All right. So let's see what's going on here. Log base 3 of 75 over 8. So log base 3 of 75 over 8. Well, I have no choice there. I have to write that as log base 3 of 75. Now, they're giving me 5s and 2s, right? So 75 is 25. That's 25 times 3, right? That's 75. Minus log base 3. 8 is 2 cubed. Okay, I think we're slowly moving somewhere. So here's the other property with the product right here. So you got 2 log base 3 of 5 plus log base 3 of 3 minus 3 log base 3 of 2, right? So what's going on? Log base 3 of 5, they call it x, 2x. Log base 3 of 3 is 1, and minus log base 3 of 2, so minus 3y. 2x minus 3y plus 1. I see it right in front of me. It is D. 2x minus 3y plus 1. Okay? Okay, 7. The domain. Now, for the domain of a log, I don't know if you remember, you can never write something negative inside the log. This has to be positive. That's it. That's how I'm going to figure out my domain. Okay, so 5 minus 2x has to be positive, which means 5 has to be above 2x, which means x. Careful of the sign here. X is smaller than, okay? Smaller than 5/2, okay? And if you use integral notation, this is what it looks like. D. Final answer. Okay. Oh, another inverse function. Okay, this one is going to be, I think, a little bit easier. Let's see. They want the inverse function. So, let's find it. What do? You replace f of x by y, and then you switch x and y, and then you solve for y. So here, let me show you. There's 2 ways you can do that. Right here, solve for y. You can, this is exponential form. You can write the log form. And so you know the base are going to be the same. So base e means for log it's ln. So ln of the output equals the input. And another way of doing that, in case, but actually this is really the most general way, I would favor this one, although you may prefer the other one because it's very nice in this case. Apply ln on both sides, okay? Apply ln on both sides. Now you got to be careful. Apply, and write this ln right here. You may prefer this right here, but you need to be able to switch from a log form to an exponential and vice versa, okay? This is more general, actually. My first method, my first approach is something I can use all the time. This, I cannot use it all the time. So look, if you apply ln on both sides, here you have x, here you have e to the 2y. And so what do you have? So here it's ln x, right? And then the 2y goes out, right? So equals 2y times ln e, but ln e is just 1. Okay, so equals 2y, and we're back to where we started. Okay, so, and then finally you solve. So you got y equals 1/2 of ln x, okay? And don't forget, this is actually just f minus 1 of x. So it's 1/2 of ln x. Do I have the answer? Let me see. Ln of x squared. No, I do not have this answer. But you know you can rewrite it differently, right? This is ln of x to the 1/2, and x to the 1/2 is square root of x. Do I have this one? Yes. You see, it was just changed. Is it going to be right? Here we go. Oh, okay. Okay. It was just changed. Okay, I think I prepared another. Okay, done with this one. I guess I can go. Okay, maybe I should go further here. If he's able to take it. I don't know if he's going to be able to take it. It's kind of messy here. Let's see. Yeah. Yeah, I think it's okay. I sometimes need to open several documents and collate them at the end, but it should work here. 21 minutes. Oh, that's a long one. Okay, all right. I'll stop here and I'll do another one, okay?